Okay, one thing we might have to determine about circles is whether a point is on the circle or inside it or outside it. So in part A, I've got to verify that this point lies on this circle. Now verify just means check. Points lying on a circle are easy because the x and y have to make the equation be true. So in part A, I just need to choose values for x and the y. Well, they're going to be the coordinates of the point. So x is 1 and y is 3. And then I substitute them into the equation. So I've got to work out x plus 2 squared plus y plus 1 squared. Well, that's just x is 1 plus 2 squared and y is 3, so this is 3 minus 1 squared. So I just get 3 squared plus 2 squared, which is 9 plus 4, which is 13, which is exactly what I wanted. Notice I let the 13 appear by itself. I started with the left-hand side and I got the 13 at the end. Now I haven't finished until I stated my conclusion. Just as with show that questions, I've got to actually end up by arriving at the conclusion they want me to arrive at. Okay, so that was part A. Now in part B, it would be tempting to try the same thing to substitute the coordinates in, but of course it wouldn't work, or it will only work if the point is on the circle, and if it doesn't work, that doesn't directly tell me whether it's inside or outside the circle. So for this we have to use a more back to first principles method. What I'm going to do is I'm going to check the distance that this point Q is away from the centre of the circle. So I'm going to need to write down the centre of the circle, and I'm also going to need the other thing that I can spot, which is the radius of the circle, because when I work out how far Q is away from the centre, I need to compare that with the radius. So given the equation of a circle, the two things from this form that I can easily write down are the centre. So this is my minus a and this is my minus b, so my a will be minus 2 and my b will be plus 1. So the centre is minus 2, 1, and the radius is, well, this is my r squared, so the radius is the square root of 13. Okay, now I'm going to work out the distance of my given point Q from the centre of the circle. And to do that, I'm just going to use the recipe for distance between 2 points. So it's a square root of the difference in x squared plus the difference in y squared, and the difference in x's, well, my x's, my Q has got an x coordinate of 2, and the other one is minus 2, so I need to take away minus 2. And for the y's, the corresponding subtraction is 2 take away 1. And of course, 2 take away minus 2 I could write as 2 plus 2. So this square root becomes the square root of 4 squared plus 1 squared, which is the square root of 16 plus 1, which is the square root of 17. And I've got to use that to answer, is this point inside, outside, or on the circle? Well, I can see that the distance that Q is away from the centre, so a little diagram might help here. Q is a distance of root 17 from the centre of the circle, but the radius of the circle is just root 13, so Q's off here somewhere, and it's further away from the centre of the circle than the root 13, so therefore root 17, I can say, is greater than root 13, so therefore Q is outside the circle. And I'm done.